everybody. We'll be starting off. Firstly, thanks for joining to all these speakers and as well as to the audience. I welcome you all to AIIM 2024, which is Accelerating Innovation and Ideas in Manufacturing. This is a session which is conducted by SolutionBuggy as part of our yearly knowledge sharing sessions. For those who have joined our previous sessions, you might have known that the webinar lasts for about 4 to 5 days, and we cover multiple topics. As of this webinar, we have completed topics on food and beverage, chemical, and electronics. The session for today is on the potential of EV technology. We'll basically look at the industry overview, current market trends for EV and its potential to grow, and also what are the contributing factors from the government which is enabling faster EV adoption. Basically, a lot of entrepreneurs are very interested in entering this segment, but they're wary of what are the kind of technology which has to be transferred, and also what kind of investment that goes in, and is there really a market that an MSME can survive in. Before I start, a quick introduction to SolutionBuggy. We are an online platform to connect to manufacturing industries to the experts. We are in fact one of the largest platforms in India to address the MSME sector, especially in the manufacturing domain. We have 12,000 plus experts on the platform and have completed 3,500 plus projects over the last 6 years. And when I say projects, it could be anything from a training program to all the way to setting up of an industry, right from concept to commercialization stage. That includes the market research, product identification, new product development, detailed project report, funding assistance, machinery procurement, plant setup, commissioning, also supply chain management as well, and a little bit on technology transfer and M&A as well. Quickly introduce myself. I am Guruprasad Kangle. I am one of the directors at SolutionBuggy and have 20 plus years of experience in consulting. I am an electronics engineer and an MBA from AIIM Bangalore. And over the next 90 minutes, we have a set of stellar speakers who will be talking about the EV sector. So let me introduce the speakers for the day. Firstly, I have Mr. Sajith Kumar, who is an automotive professional with 23 plus years of experience. He's a systems engineer and develops hardware and software solutions for automotive powertrain for OEMs in India as well as US. He is also an adjunct faculty at 𝐻𝐻𝐻 and gives lectures on automotive systems and powertrain and systems engineering as well. Next, I have Mr. Manjunath, who is the CEO of Gannett Engineering. He has 17 plus years of automotive experience and has worked with major OEMs such as M&M, Caterpillar, Cummins, and GM. He has also taught at IIT Kharagpur and is currently heading the academic programs at Gannett Engineering. A little bit strange, but both the speakers today have quite a good academic experience as well. We welcome you, Mr. Sajith Kumar and Mr. Manjunath. So the first presentation, I would call upon Mr. Sajith to take it up. So your presentation will be coming up on the screen, Mr. Sajith.
Thank you, and good afternoon, everyone. I think we can start with slide number 3. I think that makes much more sense.
Sure.
Right. So I'm the slide number, the previous slide. I'm sorry. Yeah, slide number 2 from there. Yeah. All right. Thank you. So before we get into what exactly the EV technology is, right? So I always like to start with some kind of a background about what exactly it is that we are speaking about, right? So there's quite a lot of buzz around EV, and buzz usually leads to bubbles, and if you don't really understand what's happening, so then that's basically when things starts going really wrong. And since we are speaking to a bunch of entrepreneurs, business people, and people looking for very specific solutions, I thought I'll use the first slide to kind of establish why exactly we need to be looking at this particular area, what it's going to do for us, and probably take it forward from there, right? So a couple of statistics, right? So we are kind of aware that the kind of market cap that Tesla is enjoying. We know that BYD has kind of like overtaken Tesla in terms of number of electric vehicles sold, the kind of partnerships they have, the kind of vertical integration that they managed to achieve. Now, to put it into perspective, right? So to kind of understand where this would lead to, right? So we see projections coming in from the European Union, so where they expect that only about 10% of the vehicles in the whole of European Union to be Euro 7 or higher compatible. So which is basically telling, in other words, that 90% of the vehicles which they expect on the road would probably be zero emission vehicles. Now, I'm not saying it is electric vehicles, but these will probably be zero emission vehicles. Right? So that's basically what this whole thing is leading to. I'm not able to see the screen. Should I share it from my side?
You're not able to see it. Okay, maybe you can share it.
Okay. Yeah, okay, the screen.
We will stop sharing.
No, that's okay.
Okay,
you can continue. It's come back. Back. Yeah.
Okay.
Right. So this basically gives us opportunity to look at this problem from three different perspectives. We can go to slide number 3, please. So the first one is on the slide number 3. So the first one is going to be about what exactly is happening with the batteries, which is our primary focus today. The next one is about the charging infrastructure, the charging systems. And the third one is basically going to be a very interesting area where working with quite a lot of startups, small startups, large startups. I find that there is basically a gray area, right? So which is between how batteries, battery packs, charging systems are offered today in the market, and what exactly the startups actually do require. So the problem, what ends up happening is that people either look at it from an engineering service perspective. You look at it and say, okay, hey, I'm going to charge you $30 per hour, so many man hours, give me this. Startups are not going to be able to afford for that, right? So there's a huge gray area which sits in between here. So which can either club with your battery offerings or your charging infrastructure offerings, which is where I would like to spend a little time on. We can go to the next slide. Right. So starting with the battery solutions, right? So I said there is the gap in the market, and this gap in the market is something which I've seen, right? I could be wrong, but this is something which I have identified. So what is being offered right now, I would probably, for want of a better word, what I would say is that most of what services are available to startups, most of what is available to smaller OEMs, it's basically a pack assembly service, right? So a battery pack manufacturer, though they call themselves manufacturers, are nothing more than systems integrators or assemblers. And all they do is figure out what cells that you want, what chemistry you want, either LFP or NMC, what is the size of the battery pack, little bit of a leeway on that, but nothing much more. They procure their BMS usually from China, and they integrate it, they give it to you, right? So this is basically what is happening. But the problems that startups are facing today is that all this while startups were in the product development stage, they were in the product validation, market validation. Now, for the first time, they've entered the market, And now the startups are realizing that they need to have much more of engineering which needs to be done on it, right? So they cannot go with the factor of safety. They need to kind of have more precise engineering. They need to have precise calibrations to be done on the BMS. There are also new norms which are coming up, right? So the CE certification for European Union is one primary requirement. There is also a requirement to have a product passport. This is a very interesting thing which I think can open up a lot of opportunities in the future. So this is basically the gap which I've identified, and this we are going to be looking at it from, again, 4 different perspectives. So the first is, what is it that we can do from the point of view of engineering, right? So not depend on a factor of safety where we say, okay, assume a factor of safety with about 20%, 30% headroom. We are no longer able to do that. The reason for that being factor of safety, especially gets multiplied at different stages. This is something which makes your product extremely non-cost competitive. You're going to end up with a higher cost. You're going to end up with a product which is heavier than what it needs to be. And there are going to be a lot of other compromises which is being done on the product. Now, the other aspect from engineering side is the chemistries. So the chemistries aspect is a little interesting. It's a little complicated. We'll handle it separately, but the primary one is on the factor of safety. So when I say factor of safety, what I mean is we need to do more precise engineering. We need to do CAE. We need to do CFT. We can't just say, I'll stick to 0.5 C rating, right? Just because my battery pack is not cooled, just because my BMS calibration capabilities are not that good, right? We cannot hide behind the factor of safety. We need to kind of get out and we need to kind of make our products much more better. Which brings us to the second part, which is calibration, right? So you get a BMS. The BMS is only as good as the data that goes onto it, the calibration that sits on it. So how do we make the SOC and SOH predictions? How do we calibrate this BMS? How do we make the BMS work seamlessly with other systems? How do we make it communicate? So these are things which sits on the next level. The third and fourth are primarily with respect to what kind of a USPs that you could have in case you're looking at overseas market. So you do know that manufacturing, assembling it in India would obviously have cost advantages, which means any manufacturer based out of India, and if they're looking at US or Europe as a market, they're not going to pick up a battery pack from you if you just give it to them. So they would expect you to have the CE ratings. They would expect you to contribute at least a little bit on establishing the carbon passbooks. What is the origin of the cell? What is the, there is something else on a parallel track, something called CBAM, which is coming up, right? Cross-border carbon, something, right? So this is basically something which is basically going to figure out what is the carbon emissions your product has contributed, even if it was manufactured outside of European Union. If you're going to sell it there, you need to make sure that is in place. And along with it, we will also be looking at battery state of health passports, right? So something which establishes how long this battery pack has been used, how many times it has been charged, with a certain pedigree, which can then go in towards recycling of the battery packs, second life and other things. This is basically something which helps in that. So from my perspective, I would say anyone looking at making battery packs, assembling battery packs in India, now that there are a lot of players in the market, if you want to stand out from them, then these would probably be the 4 areas which could probably be your USP, something which can set you apart. The next slide, please. Now, everything said and done, right? So this is basically at a much higher level. So now if you need to understand why exactly we need to get into it, remember I said chemistries are a pretty key area, right? So now, especially when we start talking about chemistries, this might go, above your heads. Not many of them. I'm not an electrochemical engineer or something, so I hardly understand the fundamentals. But if you need to understand what's happening here, again, going back to the basics, let's take the cell and let's look at what are the components which are there. There are only 6 different components in it, right? So the positive electrode, negative electrode, materials used for it. Then the source of ions, right? So some ion has to travel. Source of ions, in this case, we call it as lithium iron phosphate, LFP, or we have lithium-based chemistry. So that's basically what's giving you the ion. And the ion is migrating and it's getting absorbed in a graphite matrix, right? So that makes up 4 of it. Then the last 2 is the electrolyte. Current cells, they use a liquid electrolyte, and there is a separating membrane. These are the 6 components which gets into a lithium-ion battery today. Now, the primary component in this is going to be lithium. You also have manganese, you have cobalt. There's quite a lot of other chemical chemistries which goes into it. But let's forget all that, right? And let's just go and try to figure out, why is this such a big headache? Why is that governments are talking about having lithium reserves in India? Why is it governments are talking about alternate chemistries? We'll have to understand how the the geopolitics works on this. So though Australia and Chile, they are the largest, they hold the largest lithium reserves. If you look at how things have aligned themselves over the last decade or 2, China is the primary processor of lithium. China is the largest manufacturer of lithium cells. So which means, and of course, China also controls quite a lot of mines in Chile and Australia. They have forward contracts on them. So which basically means China, if they wanted to, they could use lithium as a political bargaining tool. They could, stop the supply of lithium. They can actually do quite a lot of things with it. Now, you might say, no, that will not happen. How can they basically do that? So if you don't believe me on that, all you need to do is look at what happened to the battery prices recently, right? When China holds a monopoly, no one else is even coming close to it. US, Russia, 1%, 1.5%, they don't even come close to that. Why do you think the lithium battery packs prices crashed, right? If you hold a monopoly, if it was me, I would go on increasing the price, right? So that's what was happening. But suddenly you see in 2024, the prices are falling, especially lithium iron phosphate chemistries, the LFP batteries, the prices are falling. They're down by 20%, 25%. What do you think is happening? I mean, my take is that this price drop is basically something which puts the other countries at a disadvantage. So now US is spending billions of dollars setting up their own processing unit. And now suddenly the lithium prices all over the world has dropped. No one's going to go and wait for US to put it up, right? So it's going to severely affect their production timelines. So this is, again, my individual opinion is that it is a geopolitics at play. So countries don't want someone else coming with those technologies, right? So now what is India doing? India is betting big on sodium chemistries. So what exactly is sodium chemistry? Sodium chemistry is that we just replace the lithium ions with sodium-based chemistries, right? So can you please go to the next slide? So this is the alternate approaches that we're talking about here. So one way of doing it is to replace the chemistries, right? So if you replace the lithium chemistry, because lithium is open mined, it is causing a lot of environmental damage, whereas sodium is relatively easier to mine, right? It's not going to, ecological impact is not as much. Similarly with the iron add batteries, the metal add batteries. So those chemistries are going to be like relatively easier for us to approach than what exactly is happening with lithium. Now, the second form of engineering that we are trying to do is, you remember the primary component, one of the primary components, the electrolytes, right? So the electrolytes which we use currently is liquid electrolytes. And this liquid electrolyte is what causes the extremely high flammability in lithium batteries. So now what we are trying to do is to replace the liquid electrolytes with solid electrolytes. So the moment you go with solid electrolytes, it's gonna do 2 things, primary things. One is flammability, and the second thing is probably energy density. There are still a lot of things which goes around it, but there is going to be some kind of an energy density differences. So which means probably like 3 years, 4 years down the line, we might not be so much of dependence on lithium chemistries. The dependence might go to other type of chemistries. Now, is this a good thing or a bad thing? I would say it is neither, right? So this kind of like opens your mind to be pretty open about how we approach. So what I mean by approach is, we are developing quite a lot of control algorithms. We are developing AI, we're developing intelligence, which will help us understand how the batteries are performing. So now all that we need to do is be open and try to figure out ways in which we can adapt the same algorithms to other chemistries as well. So suppose you come with iron air batteries, you come with sodium air batteries, how is your controls going to adapt for it? What is it that it's going to do in terms of like estimations, like state of charge, state of field? So that's basically what we need to be looking at, right? So now these are on the battery side. So now when we speak about the battery side, one thing which automatically comes up is how different is going to be sodium batteries from lithium batteries? How different is iron air batteries is going to be different from other chemistries? So one of the things which they're also trying to figure out is, can we go in for non-rechargeable batteries? As in, can you just replace the electrodes and can you just, like, instead of charging it, can you just replace the electrodes? Can the electrodes be replenished outside of the the battery cell? So those are also some things which people are trying to figure out. But all that apart, right, it brings us to the second part of the question. So which is all about what exactly is going to be the impact of these batteries? What is going to be the impact of this large scale adoption of electric vehicles on our power grid, right? The next slide, please. So now Niti Aayog, a graph which you see here. So this basically is something which is forecasting that the expected increase in power demand, right, by 2030, it's going to be about 100 terawatts, right? Not even gigawatts, it's in terawatts. So at 1,715 terawatts, which is the current consumption, the demand increase, which is going to happen because of just EVs, is going to be 100 terawatts. And the projected demand is going to run into 2,000 plus terawatts. It's typically like we are thinking of a scenario where we are doubling the amount of electricity production that we are looking at. Now, why is this important? Imagine it took us 76 years after independence. I'm just using it for a metric here. 76 years after independence to set up this 1,700 terawatts of capacity. And now what the projections are saying is that you need to double it in the next 10 years. We know the pace at which development happens. We know the pace at which new projects gets completed, especially something as big as a power plant. And we are looking at just a 10-year period to double the capacity. So now you might say that, okay, it's not such a big deal. We've had quite a lot of improvements in manufacturing process capabilities. All you need is $20 to $30 billion for modern day India is not a very big thing, right? I would say it's not a very big thing. So we could probably debt fund this, and we could probably go out and install that 1,000 terawatts of power. We could probably have an argument, right? But let's say like that argument is true. It brings us to the second part of the question. The next slide, please. Because what is happening is that we also need to figure out where are we going to put up the next 1,000 terawatts of power plants. You cannot just take it and put it wherever you want to, right? Because the important thing which is going to change with the advent of electric vehicles is that the power consumption is going to change. So far, if you look at it, any city, right? If you look at it, cities have a lot of power consumption usually. The rural areas, they have less. It's only the agricultural road primarily. Cities also, especially with industries and other places, daytime, the power consumption is more, nighttime, it is less. So which is why if you take, especially Tamil Nadu, for example, we have pumped storage devices, right? We have hydroelectric power plant, so which is used for generating power during the daytime. And during the night, when the demand for power drops, we use pumped storage. All the water in the dam is pumped back up. So the next day morning, again, it generates power. But imagine what's going to happen if everyone is shifted to electric vehicles. Instead of charging your mobile phones, you're going to charge your electric vehicles, right? And that's going to kind of almost even out your power demand, which means your power grid, which is designed now for a certain type of consumption, will not be okay with the consumption which comes in once electric vehicles become the norm. So which means we're looking at the way you're consuming power. We are also looking at the locations where you consume power. So now I presume a lot of you would probably be from, let's say like you're from any tier 2, tier 3 cities. You always know that there is one portion of the city which is your commercial zone, maybe office buildings and stuff. There is one area which is predominantly industrial, and then you have the residential areas. So they design it so that you have, let's say, 100 kilowatts of capacity in the industrial area, 10 at the houses, and 30 at the commercial. That's probably how the grid is designed. But now you're going to have 30, 40 kilowatts of load at your houses because you're going to charge your vehicle at your house. How are you going to manage? Right. So the first one is the time of consumption. The second one is the location of consumption. Now, the third important one is how are we going to generate this electricity? It does not make sense to again put up coal power plants. It does not make sense to put nuclear power plants. We are going to go with renewable energy resources, right? So right now, I think wind is about approximately $100 per gigawatt, and I think solar panels would probably be like twice that, right? I mean, per kilowatt hour of energy, not gigawatt, kilowatt hour of energy. Solar is about 212, 215, something like that, like the last I checked. So now what you have to do is you'll have to figure out where are we going to put up these power plants. And once we have figured out all these questions, then comes the important thing. How are we going to integrate all of these power sources which are sitting in different areas, and how are we going to bring it all into the areas where the demand is happening? So which is basically what companies talk about. They talk about vehicle to grid, they talk about microgrids, they talk about smart grid. So this is basically understanding where power consumption is needed. It's understanding what time the consumption is needed. It's understanding what type of power is coming, and then having advanced algorithms which can, club everything together. Now, of course, it sounds pretty easy and straightforward, but when you try to do it on an industrial scale, especially because it's an infrastructural process, there's quite a lot of challenges which comes in. Our grids, especially in India, I don't think anything is computer controlled, or maybe we have very rudimentary computer controls. It's not like US where a simple hack can kind of pull down your entire grid. We have very resilient systems, primarily because we've gone completely mechanical. Lineman has to come and switch on and switch off. It's not an electronic trip which works, right? So these are basically something which you would start seeing in terms of energy infra. And wherever you see these challenges, I kind of see these challenges as opportunities. So now, if you're looking at charging solutions, if you can kind of think about something like, can your charging solutions also incorporate vehicle to grid, right? So whenever there is a demand in the grid, is your charger capable of two-way power distribution? Is it capable of monitoring the current consumptions on both ways? How are you going to develop APIs or maybe some software which measures how much power your electric vehicle has supplied to the grid? Are you getting monetized for it? So now these are all the software side of things which you can look at in terms of opportunities, right? So this is basically what I wanted to cover in terms of the technology per se. So now, very quickly, in the next slide, I'll get into what it takes for you to manufacture the battery pack. So in case you decide that, okay, it is a pretty good opportunity for you to kind of get into the manufacturing of these packs. So then these are equipments which are probably readily available in the market, right? So you start with a battery cell tester, then there is a grader, sorts and grades the cells, and then you start like assembling it. And then you test it, you mark it end of line. It's basically a very well-established process. Quite a lot of players who are there in the market. But what this does not give you, what this does not tell you, is basically the story which we saw right now. So it does not set you apart from whatever needs to be done. It does not set you apart from what the requirements in the market is. So if you still need to get into the details, then you can probably like look at something like around 30 to 35 lakhs for the equipment that you see here on the picture, the battery pack assembly equipment, with a total project cost of about 1 crore. So the other cost which you would incur is going to be on your your infrastructure, your buildings, your electricity deposits, your raw materials, and of course your working capital. Now, on the engineering service side, since we said it would be probably wise for you to do some basic CAE CFTs, so that I assume would probably cost you about 20 to 30 lakh rupees onwards. So this is a very quick intro from my side about what exactly is the technology and how you could possibly like leverage these things in case you want to kind of like get into business on your own, right? So that's it from my side. Thanks for listening.
Yeah, thank you. Thank you, Mr. Sajid. The one question I think is, you mentioned that you will have to, depend on importing these units from China, and you will basically be an assembler here. So, is there any government restrictions or any kind of embargoes or things like that that the industry should be aware of?
So on the equipment side, no, there's nothing which is basically restricting us. In fact, we have some subsidy schemes going on. This would basically like qualify for any of the tough scheme, any of the. I'm not sure what is there on the other side, but at least in Tamil Nadu, there is the industrial development banks which do support these kind of things, right? The only restrictions or probably like compliance you'll have to be aware of is from the pollution control boards, which is related to how do you store and how do you dispose of the batteries. Yeah.
And also, I think in between you mentioned that recyclability is something that somebody can look at. Is this also a big opportunity for somebody who is looking to enter the battery manufacturing space?
So see the recycling part, it does not come into play right away. Whatever is there in the market size is very, very small. It does not make business sense. But what is happening is the ESG, regulations and the internal policies of the large organizations, it kind of forces them to look at end of life of the battery as well. So which means if you're getting into that space right now, even if you're not being able to kind of like make ends meet with actual business, there's quite a lot of opportunities coming, which would probably come your way when you start working with larger organizations, because that's part of their ESG goals. So you will have a lot of opportunities there.
So you will probably look like a recycler as of today, and like what you're saying is most of your funding could come from the ESG funds that the large organizations are having, and you will have to, survive until the point where recycling by itself becomes a major revenue.
Right. And even if it does come up, it is not the recycling per se. So right now, what you're doing is you are reusing the cells. You're going to use it for battery energy storage. You'll take the automotive batteries, use it for solar power or some applications. And after the solar power life is over, that is when you look at recycling per se. So recycling, that's why I said, is much more a longer thing. We still have to look for it. But you get free money, almost free money. You will probably get quite a lot of company sponsored funds which comes in, so which makes it easy for you to survive until you reach that point. And once that is done, carbon credits, right? More than the business per se, the carbon credits and how it applies, if you can wait and watch. So that is also something which will add to your top lines and bottom lines.
Right. I'll be opening up for questions at the end of the session, but before I call upon the next speaker, one other question that is also many of our entrepreneurs keep asking is there are already too many players in the battery assembly space. So is there still opportunity for new entrants?
Yeah. So you cannot just be a low cost, a low value addition provider anymore. So if you are providing value in terms of, say, you tell the startups, I'll take care of all your certification requirements. It's my headache. You just procure it from me, right? So that kind of a value addition is something which will set you apart. So the answer to that question is, unless you add value, unless you're ready to go that extra mile and do it, you might probably like not have too much of an opportunity. But then again, that's a personal choice, right? So you have some connections. There's always a dearth for assemblers. There's always a dearth for units. So you will still have something going on. But I would suggest to go move up the value chain. Set yourself apart from what China is doing. Give them more features. Give them better testing, better quality. I think that's the way to go forward.
Right. Thank you, Mr. Sajid. It was a wonderful session. You gave the entire story kind of a thing, and then you gave us kind of a bird's eye view of the entire industry. What are the pros and cons, and also who are the competitors that an entrepreneur will have to put up with if he wants to enter this technology area. And I will now call upon the next speaker, but I would request Mr. Rajesh to please hold on, because at the end of the session, again, we'll have a few Q&A as well. Thank you.
Thank you. Thank you.
So now I'll call upon Mr. Manjunath from 𝐬𝐞𝐬𝐢𝐨 Technologies. Mr. Manjunath, your your presentation will be shared. Yeah, are you able to see it now?
I'm able to see the screen.
Yes.
Hope you're able to hear me and see me.
Yes. Yes.
Yeah.
Perfect.
First of all, thanks SolutionBuggy for inviting me as a speaker for this event, and appreciate all the participants for spending your time. Obviously, we'll give you more insights in EV industry. Okay, myself Manjunath, I have 18 years of experience working with multiple companies. Okay, so I know my introduction is already done. Let's move on to next slide. My voice is audible properly?
Yes, sir. Yes, it's audible.
Yeah. A quick introduction about 𝐬𝐞𝐬𝐻. 𝐬𝐻 is our company where I'm the CEO today. Yeah, go to next slide. Next slide, please. Yeah, next slide. Yeah. So we started in 2016. We focused on two areas. One is the clean technology powertrain and safety. Coming to clean technology powertrain, we focus on advanced IC engine technologies, then electric vehicles and hybrid electric vehicles. And in safety, we focus on all the advanced driver assist systems, driverless cars, V2X, and IoT and 5G. We have 10 plus vendors around the world who we partner with for the technology part, and we are also resellers of their products. Today, our industry customers are Tata Motors, Bosch, and so we focus on working with the OEMs to, like, we develop technology, we provide technology to reduce the time taken to market. Yeah. So next slide, please. So we also have created 𝐬𝐞𝐬𝐻 Academy based upon our interactions with multiple companies. Right, we see a lot of need for manpower working in the industries. So we started 𝐬𝐻 Academy Private Limited, which is focusing only on creating an ecosystem of creating know-how to universities and do more research and develop new technologies and also create a talent. Yeah. Okay. So next slide, please. These are some of our products today. We are developing these products to mainly focus on working with multiple companies around the world to develop electric vehicle products, hybrid electric vehicles, and also IC engine products. So go to the next slide. Slide. Okay, yeah. So let's come back to let's have a little overview of what is challenges in electric vehicle industries. So before that, let me give you a perspective of what are the challenges of IC engines. The first challenges with IC engine vehicles are emissions, and second challenge is the fuel efficiency, and the third challenge is with the go next. The third challenge is the acceleration. So coming to emissions is more of government is focusing more on reducing emissions. That's what our Paris climate treaty. Okay, so then fuel efficiency is an important factor for all the consumers who are running vehicles, and also they wanted faster response from the vehicles. This is most of consumer-based response needed, and the challenges with the IC engine technology vehicles are these three: emissions, fuel efficiency, and engine response. So to meet these challenges, to find a solution, the easiest solution which is available was electric motor. Electric motor, the advantage was it doesn't have emissions, and the efficiency, if you look at here, the brake power from IC engine vehicles, the brake power is the power which is coming to the wheels. that is close to 26 to 30%. And for electric motor, it is closer to 90 to 95%. That is the reason why it is switch between IC engine to motor is being taken. Okay. So first part, emissions is addressed with electric motor. Second part on the efficiency is also addressed with electric motor because of higher energy available from the motor. And the third one, which is the response. Response is also the fastest response motor gives compared to the engine. So all the three challenges which IC engine was facing more, the electric motor handled it very well. Okay, so go to the next slide. So here I wanted to give you a little more of why electric motor and why is this technology is going to be more sustainable. Now, when we say, okay, electric motor is a good replacement for engine. Okay, but for electric motor, we need to power the motor. So there are different ways to power the motor. Okay. So one is to directly using home power supply, and one is a way to do with the rechargeable battery, or the other way is to provide a power source which generates currents. Because this slide also will give you what are the technologies changes going to be happening in the future in multiple areas. So all the electric vehicles which we're talking about in the market are rechargeable battery electric vehicles. Okay, so we're talking about only the rechargeable battery vehicles, and the way you can recharge is through power supply, home power supply. That is what is called a battery electric vehicles, or sometimes if it also has a engine, so it's called plug-in hybrids. Then if it doesn't have plug-in hybrid where you can charge the hybrid vehicle, so then that become only a hybrid vehicle which charges only with the engine waste power or braking power. So the other one is the photovoltaic cell charging the battery through photovoltaic cell. That's mainly the focus of solar vehicles. Then we have another concept which is a range extender, where we use a small size engine to charge the battery. So instead of for a car, let's say, instead of using a 4-cylinder engine, we can use a 1 single cylinder engine to charge the battery. And that is also a range extender is called as. And then the other technology which is going to come up is power source which generates current. That is a fuel cell. Okay, so in future, of course, batteries there, and we have a good perspective with respect to battery electric vehicles, and also we will be able to see more hybrids coming in now in 2024 and 2025. Okay, and range extenders, we work with few startups who are working to create range extenders and give as an kits to current consumers to increase their efficiencies. And power source which generates current, that's a fuel cell. That's a fuel cell which is going to be one more technology coming up. Like let's say if you look at heavy commercial vehicles, they are talking about right now with hydrogen engines, hydrogens. Okay, so that is the technology which is mainly focused with using fuel cells. Can you go to next slide? Okay, now, if you look at this, is a survey being done by KPMG in 2020. The focus for this is till 2030. What are the top companies? This is all over the world. What are the top companies where they are putting more investments and developing more technologies? If you look at in 2020, the result came like, okay, 52 people. This is a survey done with 980 people in 2019. In 2020, the survey is done by 1100 people who are top executives companies. So 50% of expenditure of company is going in battery electric vehicles. And the next expenditure going is on connectivity and digitalization. And the third is fuel cell. So we can see how the technologies are also being linked. So today we are talking about battery electric vehicle. We'll also have hybrids coming into picture. We also have fuel cell coming into picture. So this will give you understanding of, okay, what are the top companies around the world focusing on what technologies to develop. Okay. Yeah, can you go to next slide? Now here, you see, in this slide, if you look at, we didn't talk about the 2-wheelers, 3-wheelers, or ICE things. So this particular slide is mainly the mix of powertrains. So if you look at here, 4 powertrains has been considered. One is the IC engine, the blue color one. Then we have plug-in hybrid, which is motor plus IC engine. Then dark blue, which is a battery electric vehicle, and also we have fuel cell. Okay, so this is the main global perspective of where are they going to develop in the next 10 years.
So last slide you had mentioned key trends does not mean immediate.
Let me just go back. Let me explain that. Yeah. Go back. One more. Go back. Okay. If you look at, see, when we said take with pinch of salt as key trend doesn't translate to volume of work. So if you look at the amount of money they are putting in battery electric mobility is more, but that doesn't mean it needs more manpower also. Okay, it's not directly proportional.
Right.
Okay, so because if you look at battery electric mobility, when you wanted to make a battery, the amount of engineers needed to develop the battery will be less compared to when you wanted to work on connectivity and digitalization.
Right.
Okay.
Right.
So that's why I said if you look at that is the ranking given, but that doesn't translate to the amount of people needed.
Correct.
Yeah.
Understand.
Okay. So this focus will be like, yes, we are trying to look at batteries and fuel cells. So that earlier slide will give you perspective what is happening in the global market. They're also looking at battery electric vehicles and also fuel cells as good future along with the hybrids.
Right.
Okay. So I already given an explanation about what is hybrid, what is plug-in hybrid, what is battery electric vehicle, what is fuel cell. Okay. So here, these are the electric vehicle categories when we talk, right? Electric vehicles. So we are not talking about it's only one category. So in India, we have 2-wheelers, 3-wheelers, and 3-wheeler light commercial vehicles, and 4-wheeler light commercial vehicles, and passenger cars, heavy commercial vehicles, buses, and off-highway vehicles. Today, we see the more demand, the more entry of electric vehicles is into 2-wheelers, 3-wheelers, and both LCVs. That is the biggest demand. So the top line, that is the biggest demand in industry. Okay, can you go back? So can you go back? Yeah. So the top line, that is the biggest demand in number of. If you look at the quantity of numbers, right? That top line will have more quantity of numbers in the business. Because in the next slide we'll talk about, okay, the projections are 9 million units, 10 million units. So that doesn't matter, bring to how much in each category. But if you look at the biggest numbers comes from only the first line. Okay. So there are so many players in first line. And there are very few players in the bottom line.
Right.
Okay. Yeah. Now go to the next slide. So these are the different vehicle categories we are being used. Now, this is what is the projections for amount of vehicle sales in India. Okay. So if you look at this is again the old data. This is in 2021 data. So we don't have any new data coming from there. So 2022 the estimated was 0.7 million units. Again, this is a sum of all the categories, not one category. It's sum of all categories. Now in 2023 it was almost 2.2. Now if you look at the expected growth, see IC engines are dropping a little bit, but if you look at the amount of new entrants are more into electric vehicles. So in 2024 we are expecting 3.9 million units of sales of all EVs, and in next year 2025 it's going to be 5.6 and 7.4. So this is the amount of units which has been sold. So you see there is a huge opportunity here when we start now. Okay, so the early we start, that's the better, right? So this is the amount of units that's going to be estimated for electric vehicles. Again, you know, the first line we talked about is the bigger amount of things, but if you look at the bottom one, there it has more money, because one bus, if you look at the subsidy wise, if you look at a 2-wheeler, the subsidy for 2-wheeler is from somewhere from 5,000 to 10,000. But for a subscriber, one bus is like 40 lakhs. Okay. So the number of players in the bottom is less. The number of players in the top row is higher, because obviously it's very clear because of the cost to be invested. Yeah, can you go to next slide? Here we'll talk about, when you say electric vehicle, why are we talking about battery mode? Okay, so if you look at whole component wise cost breakdown of a whole vehicle, 40% cost is battery. Okay, Sajid already mentioned that batteries are going to be very important, and more policies are there. If you look at even for vehicles to be applicable for FAME schemes, okay, so they have certain numbers of percentage wise that much content should be from India. Now, if you look at the cost wise, 40% itself is battery. Okay, 30% itself is battery. So there are so many opportunities for making battery in India. Okay, so first is making battery in India. Second is developing new technology for battery. So which already Sajid already shared many details about battery. Okay. The second opportunity is more into the motors. Then the USP comes from the 5%, which is battery management system. The USP of working with batteries comes there. Okay, this is about the component-wise breakdown. So because for all the FAME schemes, there are you need to have 60% of India-made things. Okay, when you want 60% of India-made, if you take a 40% itself from battery, which is going to give you a very advantage, right? Okay, yeah. Move on to next slide. Now let's talk about key business opportunities. Okay, hold on. We'll talk level by level. So there are a lot of opportunities in electric vehicles, and that depends upon where exactly your interest is and where do you want to invest your time and money. Now, if you look at level 1, see, always at a higher level, developing technology is needed. Okay, in the level 1, where you want to leverage the current technology makers, okay, set up charging stations, set up dealerships, set up service stations, retrofitting, because we see more people are working in level 1, okay, at a lower investment cost, because level 1 doesn't need higher investments. It's probably less than 50 lakhs. Okay, for level 1s, so setting up EV charging stations, setting up EV dealerships, sales and service centers, and then retrofitting centers. This is more of a game which is played by many people in India. So who are trying to take level 1 and move forward. Okay. So this is the level 1 where people, if someone wanted to go for charging stations, setting up, or dealerships, service stations, retrofitting centers, the cost you need is less than 50 lakhs. Okay, again, when we talk about the level 1, it's two-wheelers, because that's the least complex. It's the least complex. If you look at the level 1, it's a completely least complex. You are leveraging the technology available and situation, all the facilities available, all the, like, if you look at a startup making a vehicle, obviously they need more dealerships. Startups making their vehicles, they need more dealerships. So that's a low-hanging fruits. Level 1 is the low-hanging fruits to set it up. Now, level 2. This is more of, okay, you are adding few more things, which is going to be a little more complex. Okay. In level 2, the easiest one again is like, say, for example, startup, they're making their own product, but they need manufacturing. Okay. So people who has a land, who has some space, interest, right? They can enter into contract manufacturing and tie up with the people who needs basically collaborate with companies where they need contract manufacturing. Even if you look at contract manufacturing, when we talk to multiple companies, right, they try to source few components and models. They collaborate with OEMs around outside India and try to bring those models, do the manufacturing here. Okay, so that they will be eligible for FAME schemes. So contract manufacturing is one area which is a level 2. Then, now if you look at, so many technicians are needed when we have more and more vehicles being on the road. Okay, training and skill development for technicians. That's again level 2. Of course, that needs a little more knowledge. You need to have people who, and they should be well versed with multiple technologies. Okay. Then you have electric vehicle spare parts and accessories areas where you can put, because if you look at even this is going to be a bigger market as many startups and companies, because spare parts are going to be much difficult. If that's the biggest problem for all the startups and small companies. Then EV dealerships with respect to the sales service of a four-wheelers. So level 1 is low complex. Level 2 has a little complexity added, but it's not that difficult. Now let's go to level 3. Level 3 is more into heavy investments, and also you will get returns fast, which is into EV leasings. So many companies are taking lease of vehicles. Okay, even if you look at Karnataka, so in �KSRTC itself, they take all the buses on lease. Okay, so that needs they will do all the maintenance, everything. They just lease it, and there are so many fleets being operated. Even for, if you look at so many fleets are there, they're giving it for cabs. They're giving it for, even say if you look at two-wheeler fleets like for last mile connectivity. Okay, or there are many places where they will want to operate EV fleets, last mile connectivities. Okay, then you have, see, if you look at the third option, which is training and skill development, which is for engineers, not for technicians, for engineers. Engineers, if you look at today, recently we had a conference where they mentioned about today in the India, so we have 50 lakh plus engineers running on road without jobs. Okay, and at the other side, see, when we're working with multiple companies, right, they are more focused on hiring more people with the right skills. Okay, so the training and skill development for engineering and technical level, that's another area. Then you have battery recycling and scrapping.
Right.
This is all the level 3. Like that needs a little higher investments. Of course, the returns also starts faster. Now level 4. Level 4 is a vision where you focus on developing technology. So Sajid mentioned about, okay, you need to work on USP. When you're working with batteries, what USP? That's a technology to develop. If you are going to develop a battery or a motor or a BMS, so that is a technology to develop. Okay, so it can be chargers, it can be vehicles fully. That's the OEMs who are making vehicles. It can be making fully on your technologies or collaboration of multiple suppliers and make vehicles. Because we see many people, even they're trying to take collaboration with companies around the world and trying to bring those vehicles here and do the contract manufacturing and become OEMs. So there are different levels where you look at investments. If you look at level 1 is the place where you see investments less than 50 lakhs and your return starts coming faster. And level 2 is again, it will be 50 lakhs to 1 crore, where you focus on putting the time and money and try to get the returns from there itself. Level 3, it really needs 1+ crore. Okay, and of course, the returns will be starting come very quickly. Level 4 is the vision. It takes more time to get the returns, but that's the more technology development and OEMs to set up your USPs, to create your brands.
It's more of a long-term vision.
Yes, level 4 is more of a vision and long term.
Right.
Okay, so that obviously needs 3+ crores.
Right.
Okay, this is the different levels where you because I understand some people wanted to start in level 1, but they will have a vision to go to level 4. So today at Gannett, we are trying to help companies who wanted to venture in these 4 areas. Technology development in level 4 and becoming an OEMs. We work with many OEMs to develop the vehicles at faster pace and create the USPs. We also create new technologies and help companies to also make their own USPs. You go back? Yeah. So we also help companies to, we are working with many universities to set up the training and skill development for engineers. And we're also helping companies to move to contract manufacturing, where We collaborate with multiple companies and try to, of course, we are also working with few startups to help with the contract manufacturing. So these are the 4 areas which we are helping companies.
I would want to ask a question tying up with what Mr. Sajith also mentioned. How is the EV charging infrastructure coming into play? Like, can there be people who can, buy chargers or develop their own fast chargers and, come into this sector?
So when you want to develop your own charger, that's a technology development. Okay, new technology, new charger, or already we have slow chargers and fast chargers. Okay,
right.
But still, if you look at still we don't have standards for even proper connectors in India. So
right.
We are going to have more technology development with respect to chargers, because that's the biggest problem with batteries, right? The charging time.
Correct.
So there is a lot of need for new technology development for chargers, and also the people who are interested in low hanging fruit, use them, develop the technology and use them to set up more charging stations. Even if you look at, right, they have so many policies right now. If you look at, government has already given to all the major companies like IOCL, HP to set up so many charging stations. Okay, when they are trying to set up more charging stations, obviously the technology will be developed by someone else. They are not going to make the technology. So there is a lot of need for making technology of high-speed chargers, and of course, safety is very important, even during chargings.
Right. And as of today, I think it is more of like a chicken and egg. As long as the infrastructure or charging stations are not there, EV adoption will be slow, and EV adoption will depend on more number of chargers being there. So maybe
that is the point where the subsidies are coming into place to push
right.
them to buy. Okay, at the same time, push them to set up charging stations. If you look at in Bangalore, we have 2,000 plus charging stations.
Right.
Okay, if you look at new apartments which has been built right now, everywhere they are putting charging stations. Okay, so that's again they are going to give more schemes to provide charging stations. So I understand it's a chicken and egg situation, but that's somewhere that there has to be motivation, right, to start. So government is trying to give through subsidies.
Right.
So the government is trying to give through subsidies. If you look at, let's take a simple example. Today, if you go to a two-wheeler showroom, ask for a two-wheeler gasoline bike or a moped, like a Honda Activa, that costs 1.25 lakhs. Okay, if you look at the same EV, they will cost you 1 lakh.
Right.
So they are trying to give you through subsidies. Through subsidies, they are trying to push the demand to reduce to give more subsidies, and so that will help people to make a decision. Okay, at the same time, they are trying to set up the charging stations.
And like how you said, in a city like Bangalore or any of the metro cities, I think it is not a big challenge. But when you go to tier 2, tier 3 cities, is where the range and the charging station and other things start playing.
Agree with that. Now, if you look at first thing, what I observed, because when these days when I'm traveling, right, I keep observing at all the pit stops. So wherever I go and stop at a hotels, right, we see more charging stations. So they are trying to connect first all the highways. So connect all the highways with all the charging stations. That will help you. So there is no problem for you to stop the vehicle and wait only for charging.
Right.
Okay. So first they're able to cover all the bigger things. See, if you look at tier 2 cities, tier 3 cities, tier 3 cities, right? If you look at, there are no major apartments lying in tier 3 cities. It's all individual houses. So if you look at tier 1 cities are having more apartments, that's where you need more charging infrastructure. If you look at tier 3 cities, will have more like individual houses where people use it directly through the homes.
Yeah.
And other way is if you look at a person who is working in Bangalore, the amount of distance the person has to travel in a day is huge. If you look at tier 3 cities, the amount of distance they have to travel is less.
Right.
So with that, see, the option wise, for a single charge, if it is giving you 100 kilometers, it doesn't have a problem with tier 2 or tier 3 cities. Because the range, the amount of distance they travel will be less.
Right.
Okay, so the good part is first getting this tier 1 cities, all the infrastructure and the highways, all the major highways, they're trying to get all the infrastructure right.
So, hello. Yeah. So I think it has been a good session to understand and scratch the surface of manufacturing by itself. So I think we have a few questions.
Yes.
Yeah. Since we are with Mr. Manjunath, I think Mr. Manjunath, there is a question on what kind of spare parts and accessories will be required, or more like what kind of investment will be required to set up a unit for that.
So coming to the spare parts business, right? See, if you look at with respect to motors, right now, if you look at in the market, right, when electric vehicle falls down, they're not repairing the motor, or they're not repairing the motor controller, because they don't have that much knowledge to repair an electric motor controller. So they are trying to do replace.
Right.
Or they're trying to do is replace. Okay. So the biggest problem with the current adoption of electric vehicles, so you see so many vehicles has been there. If you look at, go and search for the number of vehicles, there are so many vehicles are there. But the problem is the spare parts are not available so easily all around the place.
Right.
So the easiest option is to start with the similar example like Boatmo, say where you will have online sales of all these particular spare parts. If you take a Ola bikes has been all over in India right now, but the space is the biggest concern. Okay. Am I audible still? Am I in the meeting?
Yes, yes. We are able to hear you.
Yeah. So see, the companies are launching the vehicles, but they're not able to supply that space.
Right.
So, like say for example, tier 1 cities, because even when I see Ola bikes are in tier 2 and tier 3 cities, but they don't have even a place to service. Okay, and what about the spare parts? That's the opportunity to have it. So if you look at the amount of investments you need is, I said, this is into level 2. Level 2 is, it's somewhere ranges between 50 lakhs to 1 crore.
Right. Yeah.
So opportunity is there. Like even many companies, even 4-wheelers and 3-wheelers. Okay. So there are so many companies who are launching the vehicles who don't have a regular. Let's take example of TVS, Bajaj. They have their own service centers. That is where they can supply the space through. But many companies don't have service centers all over India. Yeah. So did I answer that question?
Yes, yes. So before I ask the next question, there is a small poll coming up on your screens for all the participants. I would request you to kindly take a look and answer these questions, please. It's about 5 questions. Kindly take a look and answer them. So I think my next question would be to Mr. Sajid. Mr. Sajid, are you able to hear us? Mr. Sajid there? Mr. Sajid, are you able to hear us? To all the participants, there is a poll question that is coming up on your screen. Kindly take a look and answer it, please. Meanwhile, I'm not sure if Mr. Sajid is able to hear us. Maybe I can redirect the question to Mr. Manjunath. Mr. Manjunath, people are, there are a lot of technologies that are being adopted in automotive drivetrains. Like how you also mentioned, hydrogen as one of the options, and then there is ethanol-based vehicles, and then there is EV. So, from your experience in the automotive sector, which sector will be more demand, and where will the government push the automotive sector to?
So that's a good question. So let me give you the answer. So we won't be having only one solution for every applications. So morely for two-wheelers, three-wheelers, and LCVs, we'll have more EV options. Okay. So more electric vehicles will be in the areas of two-wheelers, three-wheelers, and light commercial vehicles. Again, three-wheeler commercial and then four-wheeler commercial vehicles. Now, coming to higher, like higher heavy commercial vehicles, right, where they go long distances. So we see hydrogen is more useful there. Okay, hydrogen is more useful for a heavy commercial vehicles categories and off-highway categories where there are working in remote places. So it's a mix of technologies which we are going to have. Now let's look at even in automotive, we also have power generators. Okay, so those generators also will have more with respect to hydrogen or ethanol, biofuels, will have more. Okay, so it's a mix of technologies. Coming to two-wheelers, three-wheelers, and LCVs, the domination will be through electric. Passenger cars have a mix because today, if you look at again, when you take out passenger cars, right, we'll take a personal use passenger cars and commercial use passenger cars. So for commercial use passenger cars, electric makes more sense because the amount of distance they travel every day is huge. For a personal experiences, so it won't be having much sense. Okay, so there will be a mix of for a passenger cars, we will have ethanol, biofuel, and EV, but not into hydrogen. Okay, but heavy commercial vehicles, we see more hydrogen coming into place. So did I answer that question?
Right. Perfect, sir. So I think I have one of the participants, Mr. Kiran Kumar, who has a question. Mr. Kiran, please ask the question. Mr. Kiran, are you there?
Hello.
Yeah, Mr. Kiran. You had a question.
Yeah. Good afternoon, everybody. Just I want to ask for both list. What would the investors for if we design, manufacture, and operate EV charging system, AC and DC fast chargers, slow charger, socket or wall mounted, and in a SFT of 10,000 square feet size. So do you recommend if you go ahead with the startup project like this, and what are the opportunities we have in the present trending? I think we have many new technology tech systems already we have in the market. So where does it stand?
Thank you. Yeah.
Sajid, you wanted to answer that, or shall I?
I'm not sure if Mr. Sajid is able to hear us.
Yeah. So okay, let me from my perspective.
Sure.
Okay. So for charging systems of 10,000 square feet, okay. but charging 10,000 square feet, right? So the opportunities available are, there are one way is they are trying to use solar charging stations, okay, because that needs a huge size. One option, of course, there are so many incentives there. So solar charging stations will also attract you less operation cost. Okay. So for smaller things, we never say solar charging. Only for at least like 10,000 square feet is good to start with. So for those areas, if you really have a solar charging stations place, of course, solar charging places, charging also will be there, but you also have normal charging availability. But based on the usage of solar, you will have more ROI. Hello.
Yeah, can we get an idea of what is the approximate costing that will be required to set up the charging station?
For solar charging, I need to check with one of our vendor who works in only setting up charging stations. I can come back with the answer to you.
Sure.
Okay. Yeah.
I think in continuation of that, there is another question which basically says that, if I am going for contract manufacturing opportunities, what is the scope for it?
For contract manufacturing, see, our experience with people who started contract manufacturing is in 3 areas. One is they wanted to collaborate with OEMs outside India. Okay. So one option is collaborate with companies outside India and they already see. First thing is for OEMs who already made a vehicle, Now you are trying to give a channel to bring that to India. Okay, since that more if you look at the schemes wise, manufacturing in India. See, many people want to enter into India market. Okay, but problem is if they take they can't bring their whole vehicle and sell it. That will attract higher excess duties, and also it won't be applicable for the subsidies.
Correct.
So, like when we are working with multiple other companies, right? What we're trying to see how can we manage 60%? Okay, how can we manage? See, if you look at there is a vehicle already available in South Africa. Okay, we wanted to bring that here. Now, when we want to do that, right? We wanted to take only few key elements from there and try to do more localization. Then only we will have 60% local content.
Right.
Okay, so one option is try to collaborate with companies outside India who are already manufacturing vehicles, and bring that to India and manufacture it here and become a OEM.
Right.
Okay. Sometimes they'll say they wanted to become the OEM. They will make the same brand here, but they want only the manufacturing part.
Correct.
Okay. The other one is many startups. So we have many startups coming up. Okay. So where obviously it will be a more cost for them to invest more money and do the manufacturing also. When they are making technology, you can use it to do the contract manufacturing.
Right.
So all they need is space and you need all the equipment. Okay.
Right.
Yeah.
Right. So I think Mr. Sajid has joined again. Mr. Sajid, are you able to hear us?
I'm able to.
Yeah. So I think there are some issues with your the connection. So one question I think which has come up is, there are so many drivetrains which are being proposed from the government as well and from the manufacturers. So in future, is it hydrogen cells or is it EVs or is it ICE engines with ethanol as a blend? So what is your take on it?
Okay, so I mean that's something like there's a lot of factors which comes into play. So ethanol, we are not as advanced as say Brazil or US in terms of our ethanol production. so far. So ethanol will always bring in some water scarcity. So there's going to be some impact on the water table and other things if we try to pursue ethanol like what Brazil and US have done. So there's obviously some challenges there. So at this point, what I would suggest we do is not try to predict what the future would be, but rather like take something and stick to it. Probably try to build solutions around it, because that's how it is, right? I mean, as far as I'm concerned, electric vehicles, this is something like how your mobile phones were when GPRS first came out. So we were all excited, but there was nothing much about it. Then 3G came. We didn't have anything much. 4G, I was subscribing to 2 GB a month. And then all of a sudden there was a very different use case. And then now we are doing 2 GB per day. So what I would suggest is we are just seeing the cusp of a big revolution. We cannot predict in which way it is going to happen, or we don't even know if the mobility is going to exist like how we are thinking of it right now. So just take that example of your 5G data and keep an open mind. And I think we should remain flexible to take up whatever comes our way.
And on a lighter note, just like how 5G has been completely taken over by Reliance, we will definitely expect Reliance to take over the EV market one day. So, as long as they have not entered into the market, I think there is still scope for MSMEs to join the market.
I can confirm that Reliance is looking very seriously at this. There were some news articles which said they purchased EV startup, which basically had zero revenues but had a lot of patents for sodium batteries. I know for a fact they're working with some tier 1 providers for hydrogen engines. I mean, see, petroleum is Reliance's business, energy is Reliance's business. So anything which is gonna hit them, they're gonna obviously look at mitigating the risks. So they are very seriously looking at it. But I mean, like I said, we are too small a player to kind of predict what direction it would take. So fingers crossed, hope for the best.
Sure. Thanks. So with that, I think we have reached the end of the session. It was a great 90 minutes, getting to know the insights of both battery technology and EV through both these speakers. I'm sure the audience has enjoyed the last 90 minutes, and it has also opened up a lot of questions in their minds. In any case, if you do have questions, do write it to us. We will circulate it back with the panelists, and we definitely had a enjoyable session today. And we would thank the panelists for preparing for this session and spending their last 1.5 hours with us in trying to share some knowledge in this space. Thank you, Mr. Manjunath, and thank you, Mr. Kshetra, for your wonderful session. And we will be in touch with you. My team will be in touch with you to see if there are projects that are lined up with in this space. Thank you once again to all the participants and the speakers.
Thank you. Thanks a lot, everyone. Thank you, Manju.
Thanks a lot.
Thank you, Mr. Guruprasad. Thank you. Bye-bye.
Thanks a lot, everyone.